Okay, alright, welcome to my channel. Okay, today I'll be going through Pei Chun Public School P5 WA3 paper. This paper was set in 2022. There will be a total of 8 MCQ together with 4 open-ended questions. So basically, in the first question, we have this. We have a bird that found a picture of water but is unable to reach the water. So the bird then drops some pebbles into the pitcher and until the water level rose to the top of the pitcher, allowing the bird to drink the water. Which property of matter? Okay, so let's take a look at this part. We have the pebbles that sink in water. So it will displace the water. Therefore, the water still have to occupy space, right? So it will rise in water level. So water level will rise, and therefore this will allow the bird to drink the water. So this is really about matter occupies space, okay, which is number 2 over here. Okay, number 2. Okay, so let's move on to the next question. Okay, so we have a plasticine that's on the person's hand. He made some observation about it. Plasticine itself, you take a look, it is a solid. Okay, although it can change its shape, when a force is applied on it. If not, it will not change its shape. So therefore, it still have a fixed shape, it still have a definite volume. So let's take a look. P would be a non-metal, okay, because it does not occupy space. Then we have 2 questions. Can it be compressed or does it have definite volume? This question is related to volume. Okay, basically if something can be compressed, it has no definite volume. So since it can be compressed, this must be a gas. Okay, then we move on to the next part. Does it have a definite shape? Yes. So this is solid, because solid has a definite shape. This must be liquid. Liquid do not have a definite shape. So as seen over here, the answer must be number 3, because the plasticine itself is a solid. Okay, which is R. Okay, R should be the answer. This is number 3. Okay, let's move on to the next question. Okay, let me scroll it up. Okay, we have 2 identical beaker X and Y. X and Y with the same mass of crushed ice. He turned the Bunsen burner at the same time, and each Bunsen burner give off same amount of heat. He recorded a time interval for the ice in the beaker to melt. Okay, and he continued heating even after the water boiled. So take a look at this. That means even after the water reached 100 degrees, which is the boiling point of water, the heat was still turned on, so the water must have continued to maintain at 100 degrees Celsius. Okay, so at first we start with ice, so the ice must be at 0 degrees. Okay, and this 0 degrees continued for some time until the ice fully melt. So this will continue at some point in time. Okay, maybe this will continue for some time. So the actual graph that we are looking at, it should look something like this, in this manner. Okay, it should look like this, where we have time and we have temperature. The graph should look something like this. It continued for a while for 0 degrees Celsius, then it went up, then it reached 100 degrees. Okay, this is 100 degrees, and it continued for a while. Okay, so let's take a look at this 2 setup. So this is 1 fire, this is 2 fire. So this is 1, this is 2. Okay, so the 2 fire will produce more heat energy for the water to melt faster and achieve or reach boiling point faster. Okay, so if you take a look over here, right, the melting point must have continued for some time. It cannot straight away, the temperature will not straight away rise. So this is wrong, this is wrong. Okay, so we only left 3 and 4. Between 3 and 4, 3 will be the answer. Because when you have more heat, the melting will be faster. Therefore, it took a shorter time. Over here you can see it took a shorter time to melt. As for X, it took a longer time to melt. Okay, it should be drawn. Took a longer time to melt. Okay, then we can also see that Y achieve 100 degree faster than X. X also achieved 100 degree, but it took a longer time to reach 100 degree. So the answer is 3. Okay, it's 3. Okay, so I'll zoom in and out to annotate on the graph so that you can see it clearer. Okay, let's move on to the second part. Okay, so we have 2 glass over here, A and B. They are stuck together, so he tried to find a way to separate the 2 glass, and found it difficult to do so. So what I can do? Okay, so let's evaluate one. Pour in hot water, gain heat, expand. This one will not work because this will make it even tighter. Okay, this will not work. Tighter. Okay, so pour in hot water, loosen and contract. Yes, this will help it to loosen. Okay, it will help it to be able to separate them because it creates space for us to loosen, and the glass will be more loosened. Okay, so allow us to separate both glasses. Okay, so this one, the answer should be number 2. Okay, 3 and 4 will not be possible. Okay, because you put in hot water, it will gain heat. Okay, it will not lose heat. If you put in cold water, it will lose heat, it will not gain heat. Okay, so these are basically wrong concept. That's why it will be wrong. Okay, so question number 5. Where will the fertilized egg develop into the baby? It will be at 2, which is the womb. Okay. Okay, this is where the fertilized egg will land at, and it will develop into a baby at this position. So the answer is number 2. Okay, so let's move on to this part. Okay, so for this, the following table show the characteristics of each member in the family. A tick shows that the family member has the characteristics. Okay, so we have 3 characteristics: curly hair, single eyelid, attached earlobe. Okay, the father have the curly, no, the father has the attached earlobe and single eyelid, while the mother has the single eyelid and curly hair. So it seems like both the father and mother, right, has single eyelid. Okay, okay, so which child inherit only one trait from each parent? That means it must be one. Okay, the trait must be inherited from one father and one mother. Okay, so over here we have to look at the traits that the father and the mother has. Okay, that means we have to look at a tick that shows in the attached earlobe as well as the curly hair. We cannot look at this. It is because this one, both the father and mother have it. So we cannot use that to determine, okay, whether it inherited this trait from the father or mother. Therefore, we cannot say inherited from each of the parent. So we must look at one father and traits that is inherited from one father and one mother. So if you look at this, as long as you see a tick between the attached earlobe and the curly hair, that will be the answer. So child A, you only got attached earlobe and single eyelid. So but this eyelid, it could be from the mother, or it could be from the mother or it could be from the father, I don't know. So this one cannot be the answer. As well as B, which is the same reasoning as child A. So child C only from one father, so cannot be the answer. So we only left with D, which is one traits from the father directly, the other traits from the mother directly. So the answer must be number 4. Okay, so we left with 2 more questions. Okay, so it shows the melting and the boiling point of substance F and G. Okay, so over here we can use temperature lines to actually solve this question. Okay, the information on melting and boiling point of F and G are given, so we need to find the correct state of F and G at 140 degrees Celsius. Okay, so this is what we can do. Okay, we can draw this. We can draw what we call a temperature line, okay, as well as the both check over here. So when we draw one line here and one line here, okay, anything that falls within this region, okay, will be a solid. It will be a solid. Anything that falls in this region will be a liquid. Okay, anything that falls in the last region, okay, it will be a gas. So over here we just have to plug in the numbers, see where 140 degrees Celsius lies. Okay, for the first one, 140 degrees Celsius lies at here. Okay, here, okay, maybe you can't see. Okay, this is where 140 degrees lies for F. For G, 140 degrees lies after 129, so it should be somewhere here. So basically F is a solid, okay, while G is a liquid, so answer must be number 2. Okay, as answer must be number 2. Okay, so let's move on to the last question. Okay, Amos will conduct an experiment by placing 2 glass beakers, each containing 100 ml, in the same room. Okay, the glass beaker had different exposed surface area. He measured the volume of water that evaporated in each beaker after some time, and this was his result. Okay, so over here, right, this is the water that has been evaporated. So take a look carefully. Okay, the temperature is the same, so we can kind of ignore it. Okay, because that is not the change variable we are interested in. Okay, we will look at what is exposed surface area. Okay, so for beaker 1, you has less water evaporated. For beaker 2, you have more water evaporated. E will circle represent evaporation. Okay, so over here that means that A, right, must have a smaller exposed surface area because the water that evaporated is way lesser. Okay, so A must be less than 25 centimeter square. Okay, less than 25 centimeters square. Let's take a look at the next one. So he repeat the experiment with 2 beakers, 3 and 4, with 100 ml each. So this time round the beaker were kept at different temperatures. So we will look at this. Exposed surface area are the same, so we will kind of ignore it. So we are trying to find out where will T lies, okay, in this given information. Okay, so we will, okay, the volume of water evaporated for 3 is way more than beaker 4, so we can take it that there is more evaporation or there is less evaporation. Having said that, that means that T, right, must be a lower temperature than beaker 3 at which is at 32 degrees. So this one must be less than 32 degrees. So now we have the numbers. Okay, we just have to look which one is less than 25 while T is less than 32. Then we will have the answer. So this one, the 3 and 4 should be wrong. So in the next part, for T, we will look at the one that has less than 32, which is 14. So the answer is number 1. So from here this. Okay, welcome to the second part of the paper, which is the open-ended section. So we have 3 questions over here. So basically, Ang Xiang placed 3 objects Q, R, and S into 3 identical beakers as shown below. He added water to each beaker, and the water level in the 3 beakers were the same. Okay, so this is what happened. The object over here is sinking. Okay, and this object sinks as well, but this object float. Okay, so we have to keep that in mind as we are looking through the diagram. Okay, so all of them was at 12 cm in terms of the height of the water. So he removed 3 of the object. So the diagram below shows the water level in the 3 beaker. So K and L has the same height, while L have a higher height than the 2 other beakers. So in order to find the volume of object R, okay, we could do this in this way. So we will take 12 cm minus away 9 cm. So the object is 3 cm. Okay, in terms of the height of the water. Okay, so over here the volume of the object will be the area of the water multiplied by the height. Okay, which is we will just take it as 3. So for object S, it will be 12 cm minus away 8 cm. So you have 4 cm. Okay, so over here we have 3 and we have 4. Okay, we have 3 and 4 cm. So the last object over here. So notice that it is still 8 cm, right? So it will be more or less the same as beaker M. Okay, minus 8, so we have 4 cm. But is it really 4 cm? You take a look at this. This part over here is a floating object. So it means that this 4 cm that we are really calculating, right, is actually only this part. Okay, we have yet to account for this part that is floating. Okay, so this part over here is not accounted for. Okay, so over here the actual volume of the water, it should be more than 4 cm. Okay, it based multiplied by the area of the beaker. So over here, to find which one is the smallest, basically you can look at the numbers. So 3 cm will be the smallest. So remember as Q, R, and S. So it's not beaker L, M, and K. So many people will write beaker L and K. So you look at this, it should be R. So R, object R in beaker L. So this one you should put R. Okay, in the next part, it will be the one with 4 cm versus more than 4 cm. Of course, the one that in the middle will be your object S. Okay, in beaker M. This is object S. So in the last part, the greatest volume, okay, it should be the one that is the floating object, which is object Q. Object Q. Okay, so Ang Xiang took object Q. Remember that object Q is a floating object, and placed in a container as shown below. Okay, so and he tried to press down the object. He observed bubbles escaping out of the object. So what are these bubbles? This bubble is actually your air. The air is actually inside the object Q, inside. Okay, so when he pressed out the bubbles, right, actually water enter in. Okay, water enter into the object. Okay, so explain this observation. The observation that we are really explaining is about the air bubbles. Okay, so you can state it in this way. So the air in the air spaces in object Q, air in the air spaces in object Q. Okay, escape when he press down the object. Okay, so the key part is your air spaces escape. Okay, that would help you to solve this question. Let's move on next part. Okay, he removed the object from water. Then he fitted object Q into a cylinder. and this cylinder has a piston that you can push over here. Okay, so this object itself is wet. That means the air, the spaces, right, now contains water. There is no more, no more air. Okay, so when he pushed the piston as hard as he could, he observed that the piston did not move in. Okay, when the piston did not move in, it shows you this cannot be compressed. Why it cannot be compressed? Because it shows you the property of having a definite volume. Okay, and this is one thing that you have to relate back to your water. So this could be something that you can explain. So you can observe, you can explain what happened in Q first. So basically object Q absorb water. The water inside the spaces of object Q cannot be compressed as it has a definite volume and it is a liquid. It is a liquid. Okay, wait. Okay, so this could be something that you want to explain in your answers. Okay, cannot be compressed, definite volume, it is a liquid. Okay, so let's move on to the next portion. Okay, that is definitely not something to do with air anymore. Okay, because before we move on to the next portion, definitely not something to do with air because this is wet already. So it tells you that the air spaces has been filled up with water. So when you read or when you attempt to do part C, right, you must do it in conjunction with part B. Part B is about air escaping, while part C is about when all the air escape, the water must have entered in that object. And then from there, the object cannot be compressed anymore because it is a liquid and it has a definite volume. Let's do question 10. Okay, basically Hannah placed or put plastic and metal plate in the refrigerator overnight. Okay, plastic, okay, wait. Plastic and metal in the refrigerator overnight. When he removed both plates at the same time, the fan felt that the metal plate was colder than the plastic plate. Okay, so her hand was touching on the cold metal plate and cold plastic plate. Both of them, they are cold because they probably already lose, they are in a refrigerator, so both of them will lose heat to the air in the refrigerator and the temperature became lower. Okay, so state whether the temperature of the metal plate is higher, lower, or the same as the temperature of the plastic plate as she removed both plates. So the key is, some of you may think that it is lower because her hand felt colder. It's not the case. Okay, they are actually at the same temperature. Okay, both of them, they are actually at the same temperature because you have to remember that both of them are placed in a refrigerator overnight. So both of them will lose heat until they become the same as the surrounding temperature or there is no more heat flow. So in this case, both of them, they are at the same temperature. But why, when you pick up the metal plate, it is colder than the plastic plate? Is because of the way that they conduct heat. Okay, metal itself is a better conductor of heat than plastic. So your hand felt colder is because your hand lose heat to the metal plate faster. Therefore, your hand felt colder. It's not because it is at a lower temperature. So over here in the second part, explain why your hand felt that the metal plate was colder than the plastic plate. Okay, so first part, you have to state metal is a better conductor of heat than plastic. Okay, so next up, you have to link up colder. What is this object that it felt colder? Your hand. And this is the second object. So your hand felt colder is because your hand lose heat faster, and the metal plate itself gain heat faster from your hand. So next part, you can link it that her hand lost heat to the metal plate faster than plastic plate, so it felt colder. Okay, so this is the key explanation. Okay, so lose heat to the metal plate faster, therefore it felt colder. And another point is your better conductor of heat. Okay, so Hannah placed a block of ice on a plate at room temperature. Without heating the ice, what can she do to make the block of ice to make it melt faster? That means you cannot heat it up. Okay, explain your suggestion. Okay, there are a few ways to go around it. Okay, so you have a block of ice, so that means you have a let me draw it out. You have a plate and you have a block of ice onto it. First, you can either do it by breaking them up. Break the ice up. So what you are trying to do, you are trying to increase the exposed surface area to the surrounding air. Okay, so that it will gain heat faster or at a faster rate, and it will melt faster. Okay, this could be one thing that you want to do. Okay, the next up, the second part is that you can do what? Add salt. Okay, then you can say what is function of adding salt. Okay, adding salt will lower the freezing point of ice such that the ice will melt faster. Okay. Okay, this could be another key point that you want to state. So between these two, just choose one of the suggestion is good enough. Okay, so let me okay, maybe for this part I'll write it in exposed surface area of the ice cube or block to the surrounding air, and it will gain heat faster and it will melt faster. Okay, gain heat faster from the surrounding air. Okay, so this is okay. Another part. Okay, the diagram below shows two types of cells. Okay, two types of cells during a process in the reproduction of human. Okay, so basically this is your sperm cell and this is your egg cell. Okay, name two organs in the human reproductive system that produce. Okay, so you want the organ that produce the cells. Okay, so this will be your testis and your ovary. And the process, okay, so since the sperm already enter the egg cell, okay, so this process will be your fertilization. Okay, this process is your fertilization. Okay, let's move on to the next part. Okay, Ye Yan took a pack of chicken and wrapped it in clear plastic from the refrigerator, and the mist was seen near the pack as it was taken out. Okay, then I told you about water droplets were seen on the plastic after some time. Name the state of the mist. So state, right? Name the state. So you can only have 3 states: solid, liquid, or gas. So this mist is actually formed by your tiny water droplets. Since it is water droplets, it must be a liquid state. Okay. So over here, explain how the water droplets will form. Okay. So in this process, right, it's basically your condensation process where the water droplets is being formed. Okay, but you have to explain it fully. So first part, you see that this was taken out from a refrigerator, so this must be way cooler, or rather this is your cooler surface area. Cooler surface area. Okay, so there must be a source of your warm water vapor. This source of your warm water vapor, right, should be in the surrounding. Warm water vapor is in the surrounding air. In the surrounding air. Okay, it must have come into contact with this cooler surface area of the plastic. Okay, so try to use the word that has been given. So since they give you this surface, right, so you try to use this. Okay, and it must have, after they came into contact, it will lose heat and condense into tiny water droplets. So this is one way that I will do it. Use this one. Okay, so these are the steps that will be needed for you to write it clearly. Okay, so the starting state will be your warm water vapor, okay, in the surrounding air. In the surrounding air, heat transfer will be loses heat to the cooler outer surface of the plastic wrap. Okay, you can be as concise as possible. Okay, so usually it'll be better, okay, if you write the word cooler outer surface, because sometimes it can be cooler in the surface depending on the context of the question. So lose heat, then it will condense into your tiny water droplets. Okay, tiny water droplets that was found on the surface. Okay, she then took another similar packet of chicken wing from the freezer this time round and placed it on the table. After a while, a thin layer of white solid was found on the surface of the plastic wrapping. So we have a chicken wing wrapped with plastic. We have a thin layer of white solid found. And explain why the white solid found. Okay, so in this case, the white solid was found, right? It is probably in the process of freezing, because you have to understand this is the ending state. Solid is the ending state. Where could it come from? It must come from a liquid state, and this liquid will probably be something that is related to your tiny water droplets. So this is actually an extension of your condensation question. Okay, so the liquid, the tiny water droplets in the liquid state to go back into a solid state, it must have loose heat. Okay, and then it must have freeze. Okay, but what did it lose heat to? It probably lose heat to the same surface that we have been talking about, which is the cooler surface of the plastic wrap, because the white solid was formed of it. It must tell you that the water droplets must have loose heat to the surface of the plastic wrapping. So in this case, the surface of the plastic wrapping, right, must be even way cooler. Okay, so this is another way that we can do it. Okay, we can see the water droplets lose heat to the cooler plastic wrapping and freeze. Oh, froze into white solid, which is your ice. Okay, the white solid cannot be seen after some time. Okay, that means the white solid is no longer there anymore. It probably have changed from a solid to a liquid state again. In this case, it will be a gain heat process, and it will be, since solid change to liquid, it must be melting that is involved. So using the same similar step, we can use this one. The starting state will be your white solid. You can talk about the white solid. Okay, gain heat from. Where did it gain heat from? So you take a look. The white solid is found on the plastic wrap, and it was being placed on the table. So on the table, it should be way warmer, okay, because it's at room temperature. Right? It's at room temperature. So in this case, you can assume that it is gain heat from the warmer surroundings, okay, and melt into your water droplets. Some of you may even want to consider this. Okay, you can even say this as well as an extension. So after writing this, you can add on to say that the water droplets, which is the ending state of the melting process, okay, it actually evaporate off into your water vapor. Okay, because it is no longer seen there anymore, right? So you can go on to say that it probably had evaporate off into water vapor as well. So you can say these water droplets gain heat from surrounding and evaporate as water vapor as well, because it's safe to assume that after the ice has melted, probably some of that water that reached to room temperature could have also evaporated off as well. Okay, so that will be the end of this paper. So you can pause throughout the different section of the video and then look through the answers again if you're unclear on certain parts. Okay, thank you very much.